Hi, everybody. Today we are simply going to review what we've already learned about piecewise linear functions. We're going to go through 4 separate problems. I will show you how to do the sample problem. You will do a copy of that on the next slide. We will move on to the next one. We should be able to do this very quickly and very efficiently because you all already are partial masters at least. Okay, the first question asks us to find the equation of the piecewise linear function shown here in a graph. What we need to do is we need to figure out what the equation of part 1 is here and what the equation of part 2 is. Those are my 2 pieces of my piecewise linear function. If I figure out what the equation and what the domain is, I am done. Okay? So for the first one, number 1, what is the domain? Well, think about what domain means. All the possible x values. All the possible x values are right here. The highest possible x value is x equals 3. Okay, you see how x equals 3 is the biggest that that graph gets. Okay, so what we say is that the domain is x is less than or equal to, because it's got a filled in circle right there, so that's less than or equal to 3. Notice how the graph goes on forever and ever, signified by that arrow right there. So it is simply x is less than or equal to 3. It's not an interval, just less than or equal to 3. Okay, so I found my domain there. On the next piece, I want to find the domain of this guy. Notice it too goes on forever and ever. This time it goes to the right. But again, the lowest possible value is 3. And because we have an open circle right here, we can't actually hit 3 even. So what we say here is that the domain is x is greater than 3. Not greater than or equal to, just greater than. Okay? Okay, so our first part is done. I'm going to write f of x equals, leave room for my equations, and I know that I have to put, the first one is 4x is less than or equal to 3. And the second one is going to be 4x is greater than 3. I don't know what my equations are yet, but I know that that's what part of my piecewise function is going to look like. Now I do the rest. I'm going to erase everything here so I can see this clearly. And I need to figure out, let me first draw back in those numbers, 1 and 2. Now I need to figure out what the equation is for each one of these lines. Let's do 1 first. Well, I'm going to use y equals mx plus b. And to find my y-intercept, I just look at the graph where it crosses the y-axis. Well, that point is going to be -4, or that, yeah, it crosses at -4. So I write y equals mx minus 4. Now all I need to do is figure out what my slope is. And remember, your slope is simply your change in y divided by change in x, or rise over run. So if I draw this kind of triangle right here, how far did I go down from my first point, which I'm filling in right now, to my second point there? Okay, how far is that? Well, I went down from -4 to -9, so that's down 5, minus 5. And then I went to the right, 1, 2, 3, so that's plus 3. So my rise over my run is -5 divided by 3, so, or -5/3. So when I go to write my equation, it's simply y equals -5/3 x minus 4. Okay, so I can go ahead and write this in. Y, or not y equals, I'm sorry, we already have our f of x. So all we're going to just say is f of x equals oops, get my pen back, -5/3 x minus 4, for x is less than or equal to 3. Now for part 2, it's a little bit trickier because I don't actually have my y-intercept. A couple of things you could do there. You can use use 2 points instead of 1 and use the point slope formula. Or what I'm going to do, I'm just going to extend my line. I'm going to erase all of this first. I'm just going to extend my line Um, sorry, let me undo that. I'm going to extend my line so that I can figure out where it would cross the x-axis, or the y-axis rather. Okay, and it turns out it would cross at -10. Okay, so I know my y-intercept is going to be -10. Okay, so I know it's going to be y equals mx minus 10. All I got to do now is figure out what my slope is. Again, we picked 2 points. We've already got one right here. Let's try to find another one on my graph. Looks like this one right here. Figure out what is my rise. Well, that's 1, 2, 3, 4, 5. So plus 5 because I'm going up. And then how far over? 1, 2, 3, plus 3 for my run. And so my rise over my run is simply 5/3. So I have y is equal to 5/3 x minus 10. And so I am ready to write my equation. F of x equals -5/3 x minus 4 for x is less than or equal to 3. And f of x is equal to 5/3 x minus 10 for x is greater than 3. That is all there is to it. I am done at this point, and I can move on to the next problem. Okay, so I'm going to allow you guys to do this next one. Sorry. I'm going to allow you to do this next one on your own, and then I'm going to move on to another problem. This one is exactly the reverse. I am given the piecewise function and asked to graph it. Okay, so the first thing I'm going to do here is I am going to draw a line where the restriction is. The restriction is less than or equal to 3 for x is less than or equal to 3, or x is greater than 3. So I'm going to draw my line at x equals 3. Remember, the equation x equals means it's a vertical line. And I'm just going to draw that. I'm going to make it dotted so we can see through it. I'm going to make it a bright color so that we can't miss it. And that is the line x equals 3. So what I'm going to do, I'm going to say that one of these equations, either this one here or this one here, has to be on the left, and the other one would have to be on the right of this line. Okay? Now all I'm going to do is I'm going to figure out which one is which. Okay? So the one on the left is going to be the one where x is less than or equal to, in this case, 3. So I know that my first one, 1/2 x minus 2, is going to be the graph that I put on the left side. Okay? So 1/2 x, my slope is going to be 1/2. My y-intercept is going to be -2. So I'm going to start with my y-intercept. I go down 2. I put a point. Okay? Now what I'm going to do is I know my slope is 1/2, and that means I go up 1 over 2. So I go up 1 over 2, I get a point. Up 1 over 2, I get a point. Up 1 over 2, I get a point. Now some of you are probably saying, you're going too far. So what you could do instead is go, instead of up 1, right 2, I could go down 1, left 2. Down 1, left 2. At this point, it's pretty obvious what our graph is going to look like. So I'm just going to draw the line. I'm going to draw a solid line, and I'm going to make it red so that it is the same color here. And I'm going to do this. And notice, I am not going to go past the line. I'm going to stop at this x equals 3, because I can't go past there. But I then need to see what kind of circle do I put at the end of my, my line. This is going to be x is less than or equal to, so I know I need to put a solid circle at the end here. And do not forget, you need an arrow head to finish off your line. And I'm just going to label this as well. This is 1 half x minus 2, or h of x equals 1 half x minus 2. Okay, next thing I need to do, I need to graph the other one. Notice this one, some of you might be a little bit tricked out by this one because there is no y-intercept. In fact, there is a y-intercept. It is plus 0. So I know that my y-intercept is going to start right at my origin. I intersect the y-axis at the point y equals 0. Okay, so from there, I just follow my slope. My slope is negative 2, which means negative 2 over 1, means I go down 2 and right 1. So I'm going to go down 2, right 1, 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 and we get the idea. Of course, we know that all of this has to be on the right side because we are talking about the domain being x is greater than 3. So it all has to be on the right side of this peach line that's vertical that I've drawn in. So what I need to do now is I need to draw a line. I'll make it purple to match my color. And I need to draw a line that matches this. However, I cannot go past what I had. I can't go to the left. So what I need to do is I need to restrict this so that it only starts at this line. Okay, I'm going to erase all the points, and then all I need to do is figure out what kind of dot do I need? What kind of arrow do I need? Okay, so I know that this is going to be x is less than 3, which means I have an open circle because it cannot actually equal 3. Open circle here, and as always, an arrow on the right saying it goes on forever. And then I'm just going to label this graph. This was h of x equals negative 2x. Okay, and I'm done. That's all there is to it. Then what I'm going to do is I am going to evaluate these functions here, h of 0, h of negative 3, h of 3, etc. And the way I do that is I'm going to grab all of this. And I need to figure out which one, for each of these evaluations, which one do I use? Well, for h of 0, 0 is actually going to be less, or yeah, it's going to be less than or equal to 3. So I'm going to use this first equation, 1 half x minus 2. And so what we do, we say h of 0 is 1 half x, which is 0, minus 2. 1 half of 0 is just 0. So h of 0 is going to be just negative 2. H of negative 3, again, negative 3 is going to be less than or equal to 3. So I'm going to say, I'm going to use the same equation. H of negative 3 is 1 half times x, which is now negative 3, minus 2. 1 half of 3, or 1 half of negative 3, there are no common factors, so I just multiply across. I get negative 3 over 2 minus 2. However, this is not, you can't combine fractions unless you have a common denominator, so I make this 2 over 1, and then I need to change that by multiplying by 2 over 2 to have the denominator both be 2. So I get negative 3 over 2 minus 4 over 2. And then all I'm going to do, I keep my denominator the same. It's going to be over 2. And I do negative 3 minus 4, so I get negative 7 over 2. And so I know that h of negative 3 is negative 7 over 2. I'm going to grab all of this. I'm going to shrink it down so that I can move on to the next one. And I'm going to do h of 3. Now here's the tricky one, and it's the reason I put 3 on purpose. Which one do I use? They both have a 3 in it for the x. We use the one that can actually equal 3. So again, this first equation can work for x is less than or equal to 3. So I'm going to use that equation. I go with h of 3 is 1 half times 3 minus 2, which is 3 halves minus 2. This is looking very similar to the last one, except that I now have 3 halves minus 4 halves. 3 minus 4 is negative 1, so I have negative 1 half. And that is my answer. H of 5, for H of 5, I look where is 5? Well, 5 is going to be bigger than 3. So what I'm going to do, I'm going to use this one here. Negative 2x is my formula that I'm going to use. So H of 5 is negative 2x, or negative 2 times my input value, which is 5, which is just negative 10. That was easy. And finally, H of 2/3. Nothing says they have to all be integers that are our inputs. 2/3. I have to ask myself again, is 2/3 less than or equal to 3, or is it greater than 3? Well, clearly, it is less than or equal to 3. So I, again, am using my first equation, 1/2 x minus 2. Okay, 1/2 x, which is 2/3, minus 2. Could we please stop?
What did we do? What did we do?
Hey, sorry, everybody. I had to scream at a student. I apologize. I was frustrated. I'm not going to refilm the video, though, so you guys get to see that Mr. Duncan occasionally loses his temper. Surprise, surprise. All right, so we were trying to figure out this last one, 1/2 times 2/3 minus 2. Remember from the beginning of the year that fractions are our friends when we have a common denominator, or a common factor, rather, in the numerator and the denominator. I can just divide by it. I have a common factor of 2 and 2, so I divide both of them by 2. They both become 1. And what do you know? I've got 1/3 minus 2. And then I'm going to need a common denominator to combine these. So multiply by 3 over 3. 1/3 minus 6/3. 1 minus 6 is negative 5. So my answer is negative 5/3. And don't forget that the way we write this is h of 2/3 is equal to negative 5/3. And the same thing with all of those answers. H of whatever input I put is equal to my output. So for this one, h of 5 is equal to negative 10, etc. Okay, so you've got one to try on your own, and I'm going to move on to the next one. Here we have two tables. This should look familiar. Two tables that represent the two pieces of a piecewise function. I want to graph the function and write the equation for the piecewise function. Okay, well, graphing is actually easy. All we have to do is graph these points that we have right here. 0, 8, 1, 6, 1, negative 6, 2, negative 4, 3, negative 2, and 4, 0. If I graph those 5 points, I can then just draw a line. Okay, so what I am going to do is I am going to find my pen of the appropriate color. I want to try to make these the same color I had drawn them in. Okay, so I have 0, negative 8. 0, negative 8 is this point right here. The point 1, negative 6 is right here. 2, negative 4 is right here. 3, negative 2 right there. And 4, 0 right there. I'll figure out where to put my arrows later. I'm going to skip to the next one and draw those 5 points. 5, 0 is right here. The next one is 6, negative 2 is right there. 7, negative 4 right there. 8, negative 6 right there. 9, negative 8 right there. Okay, so and the way that we just complete the graph, that one's going that way forever. We assume that way, that one's going that way forever, we assume. And you can't really assume anything about the middle, so we're actually just going to leave a hole there.